So for this lab, we're going to use a new piece of equipment called a burette, which is right here. We're going to use this instead of a pipette to dispense acetic acid into this beaker where you'll have your test solution. So if you're following the directions, I think up to step 8, you should be able to follow just as written, which includes mixing NaHCO3, which is sodium bicarbonate, with 50 milliliters of water. That's going to be your test solution. And also setting up SparkView on your device and connecting this, which is your pH sensor. Then you're going to place your pH sensor into the flask. This will probably already be removed. This is just a storage bottle on the bottom. If it's not, you can let me know because I want to keep those in a safe place. And you'll put your connected pH sensor into this beaker. Okay. The pH sensor is pretty sensitive, so make sure that you are kind of stirring the solution with the pH sensor periodically so that it's getting a mixed version of your solution. You're going to predict how much acetic acid it will take to neutralize that sodium bicarbonate solution. And instead of using drops, we are going to use milliliters because we found through practice that it takes a lot of drops. So it'll be easier to use this burette and measure in milliliters. And the way the burette works is as it drops or dispenses liquid, the level drops. So you want it to start out full all the way up at the 0. So I'm just going to demonstrate. I have some acetic acid here. Okay, I'm going to wear my glasses. There's a funnel here. And I'll be honest, like I'm not super tall, so you might want to have a tall person in your group help you with this step. But I'm going to pour acetic acid into the funnel until it's filled up to the 0. So I'm going to do that carefully. There we go. And you want that to be as close to the 0 as possible. So maybe lift up the funnel and check the level. That way, as you dispense the acetic acid, the level will drop and it will tell you how many milliliters you have added. So when you get to step 8, where it says using the pipette, we're going to use the burette to drop acetic acid into the solution. Try to start it out slow, so turn this very slowly until it's dispensing just drops. So I'm just holding this with one hand and turning this slowly until, there we go, until the flow is in a drop. So one possibility is that it could go slowly like this, where it's just dripping. If you find that you need it to go a little bit quicker, it's okay to dispense a little bit more and then slow it down again back to drops. Okay, what you want to make sure to do is stop the acetic acid when the pH sensor reads 7.00, because this is a neutralization reaction and we're going to be looking for a neutral product. So keep dispensing acetic acid until the pH says 7.0, and then at that time you're going to stop the acetic acid from flowing. You're going to make sure to swirl this, double check that it says 7, record the final pH, and then you're going to look up here just like you would at a graduated cylinder. And in this case, I added 1, 2, 3.5, a little bit more than 3.5. If possible, I'm going to get up on eye level. Looks like 3.6 milliliters. So I would record 3.6 milliliters, the final pH, and then I would use that information to help make a prediction for the next step. You're going to repeat the same process 3 times. Each time you can dump out this solution and replace it with 50 milliliters of water. And for the following 2 trials, you can decide how much sodium bicarbonate to use. So that will be your part of the experiment to design. But you're going to work on making like a better and better prediction each time of how much acetic acid it will take to neutralize that sodium bicarbonate. And then when you're finished, you can rinse the test solution, and you can also rinse off the probe. So this beaker here is labeled waste. That's just for rinsing the probe. So I'm just going to rinse the probe with distilled water. And then you can leave it in the distilled water, but I will eventually be replacing the storage bottle.